my name is Lenny Jaramillo from Northern Trust, and I'm here to talk to you about how we're migrating away from our big data architecture to do more with Spring Cloud, running on Pivotal Cloud Foundry. But before we get into the discussion, there's two things that I'll ask folks. One, if you can rate the presentation afterwards. Once you accept the presentation itself, you can then rate it afterwards. The other question that I have is, how many of you are actually using Hadoop in some processing today? By show of hands. Awesome. How many of you that are using Hadoop actually have difficulties meeting SLAs, KPIs, moving data around, and stuff like that? Still? Yep. So at least I know we're not alone in this adventure. So let's get into it. First, our standard disclaimer. All information, as you know we're doing publicly, is not intended for investments and stuff like that. So when we start thinking about our big data platform, big data itself, big data really was the fad 5 years ago, right? And big data is going to help solve all of your problems. No matter what the problem was, throw big data at it, right? If you had problems with, moving data, solving analytics, whatever it was, big data was the solution to that problem. So as a result of that, right, so a lot of companies invested a lot of money, a lot of effort into big data, training classes and whatnot, just to get people acclimated to it. As they started writing their pipelines, moving data around, they started realizing that big data is really meant for petabytes and stuff like that of data, not necessarily gigabytes of data and whatnot. And you're missing SLAs, you're spending a lot of time writing code, and you're not really meeting the value, the business value, and the outcomes that you strive to do. So what we're looking at doing is how do we actually use, at the time, using our big data environment, moving to a message-based system to solve our client warehousing needs, solve our digital footprints, and whatnot. And that's really where we started from with our big data architecture. So what we're going to do today is we're going to talk a little bit about some of our challenges with our big data, why we pivoted, how we did, and really where we are now. The most interesting stuff that we're going to talk about is how we pivoted and really where we're going towards, because we're really pushing forward. Every time we hear the word no, we just keep asking why and keep pushing further on. So when we start thinking about that problem again, our business use case, as I was talking about earlier, is to create an enterprise data warehouse to support client needs through reporting, data warehousing feeds, digital experiences. We're a company that's been around for over 130 years. So we already have an established client base of customers that get the data warehousing feeds, printed reports, online reports. We're going into a new adventure with APIs and API delivery for our consumers. But there's all these digital experiences that we have to continue to support as we start changing how we're moving data around within our organization. So our clients and our partners, they have this level of expectations of data from us, and we have to ensure, as we're going through this journey, that we continue to deliver value on what it is we're going to. Our clients rely on this data for financial decisions, regulatory reporting, as well as their own client reporting. We are moving some of our mainframe systems and AS400 systems. We are a big bank, so we have mainframes and AS400s that we're reading the data from to satisfy our data warehousing needs. So kind of a current state. This is really one of our accounting engines. This is our domestic accounting engine, and you can see the spaghetti, the mess of everything that's going on. Trying to migrate a spaghetti like this into something that is a tangible asset is really difficult, requires a lot of manpower to be able to get to the outcomes, the business outcomes that we're striving for. So our first go-round, this is what we created. This probably started 5 or 6 years ago, really with our Hadoop system. So looking at the diagram itself, the components on the left really look at our systems of record. So as you think about the mainframe systems, the AS400, or any other type of even system like off the shelf that you would buy today, you have some form of a system of record. There's no surprise that an organization of our size actually has multiple systems of record for accounting, or account master, security master. Our actual account master, last my count was we had 4 different account master systems. 4 systems to harmonize and to get a consolidated system of record that you can then use for client reporting is no small feat. So once we did bring some of our data into the big data system, we actually created it on a source folder structure on HDFS before we would move it to what we call land and archive. Land and archive, the differences really between the two, archive would essentially be the raw untransformed data. Land, we would actually do some modifications so we can actually understand what the data is. We then moved this data itself, so we'd have to apply schema on write to get the data to a Hive metastore, which is essentially within Hadoop how you can actually leverage the data from an Impala system. So Impala is ETL. It's like SQL for Hadoop, for those of us that have been using Hadoop for a while. So we used Impala to try and get data out for our data processing pipelines. We'd write the queries and whatnot, and over time, because we're doing ETL within the SQL, it became increasingly difficult. Since Hadoop itself is an immutable database, there's no such thing as an update or a delete. So you're adding more and more data to your Hive metastore. So your queries that you'd write on top of Hive to get the data out became increasingly complex. Again, SQL is not necessarily an ETL tool. At the time, Pig language was not necessarily strong in the marketplace. About a year or two after we went through with this, we started looking at Spark again because Spark became a stronger player in the space. Even with Spark, it gave us some capabilities with XML and JSON, but Spark itself came with its own level of baggage. And Spark did help with some use cases, but Spark also created its own baggage as well, which made things a little bit more difficult. This illustration is actually a simplified version of what we had to do. Going from the Hive itself, I mentioned earlier, we created multiple systems, or we have multiple systems of record. We consolidated those systems of record with our common record transformations, where we harmonized those sources together. We harmonized the sources so we can deliver that data to our data warehouse. You'll also notice there's multiple recycle processes here. We have an immediate consistency model. So in order for us to have those common record transformations, we needed all the static data together with the actual transactional data, so we know when we create this information within Hive and then eventually on the data warehouse in Oracle, we needed all that data to be immediately consistent. So everything had to be together. So we would run these reject recycle processes multiple times, and it'd go through 2 iterations before the data was actually ready for consumption into our data warehouse. So not everything with Hadoop is bad. Actually, Hadoop is very good. Hadoop is very good for certain use cases. We used Hadoop for data processing, and Hadoop is not necessarily good for the data processing that we were using based on our experiences. So Hadoop does work well when you're using it to land raw system data, where you understand what the fields look like, so you can really take advantage of schema on read. Hadoop also works very well when you're trying to pull data sources from your systems of record every couple of minutes. Small files don't work well on Hadoop, but larger files do. So the larger files from your systems of record where you're pulling data, the 3 to 5 minutes as I mentioned earlier, they're usually pretty large. Maybe not quite a gigabyte, but they're still pretty large. So the change data captures from your source system reading that database log is really a good use case, as well as the flat files with the defined columns. But now let's get into some interesting stuff. What really didn't work well for Hadoop is we treated Hadoop like a database. Hadoop, we treated it as a database as well as a data processing engine. It caused a number of challenges with missed SLAs as a result of that. Its inability to handle those open system formats, so Hadoop itself natively did not support JSON and XML. Spark was the answer to help us with some of that stuff, but that didn't necessarily work out. I mentioned earlier we used Hadoop as the operational data store, and its immutable aspect of it caused challenges as well with the partitioning and stuff to pull data out of Hadoop. And then the replicated reject recycle components really had a big impact on what we were looking at doing. So we had to pivot. We spent enough time on Hadoop, we learned that it wasn't necessarily going to be sustainable for us as we're trying to work through our 15-minute SLAs to get data from source to client reporting with delivered reports, digital experiences, printed reports, and all that stuff. So we had to pivot. Why we pivoted is for a number of reasons. We had to look for alternatives. The automated testing for ETL is extremely difficult. Essentially, it's really hard to do, and we have not been able to find a good way of doing it. And even trying to do automated testing on SQL ETL is nearly impossible. Our time to market, we're looking at development cycles on our Hadoop side of months to years. So we would do quarterly releases if we were lucky. Most releases were actually semi-annually. We did need a specialized skill set, so we trained a significant amount of our employees to be able to learn how to use the Hadoop ecosystem and learn the languages like Impala and Spark and other components of that system itself. And needless to say, I'm up here because we're talking about the commitments that we missed, the milestones that we missed, and the deliverables that we missed. Because if we made all of them, we wouldn't necessarily need to pivot from Hadoop, would we? So what we did was we actually started working with our Spring engineering teams. Northern Trust and Pivotal have been aligned on a number of efforts over the past 4 years, 5 years actually. So working with our Spring team, we went through a 3-week POC on Spring Cloud Data Flow. Our team itself worked on daily experiments on how we could actually migrate from a big data architecture to being cloud native. The Spring engineering team was instrumental in ensuring that we were able to meet our goal to migrate to a cloud native architecture. The purpose of the exercise was not necessarily to get a working application in production, but to show that there is life after Hadoop, to show that we can actually build a cloud native application to move our data without relying on Hadoop and the pipelines of Hadoop itself. So we did it, and we were able to create an application. We iterated multiple times to be able to prove out what we were looking to do. From that aspect, we then said, our friends at Chicago Pivotal Labs, let's do a labs engagement. We had to prove again to our stakeholders that we can get an application in UAT working, moving data, creating an API for one of our application teams. We worked through our experiments, we worked through our architecture iterations. We had folks from the Spring engineering team, the Spring data team, and the Pivotal Labs team all working together at the Chicago Labs. It was a unique adventure for Pivotal as well as Northern Trust because Pivotal itself has not necessarily done a lot of opportunities bringing all 3 parts of the organization together for a defined customer business outcome. And so we worked together to ensure that we were able to meet the business outcome. The engagement itself was an emotional roller coaster, I'm not going to lie to you. We had to prove the viability of this architecture. We had to be able to prove the components that we were looking to do, and we were forced to make lean data decisions on what to build, and more importantly, when to build it. We did iterate extensively on the happy path for the first couple of weeks to prove out what we were looking to do. So that resulted in a number of iterations that we would have to go back to ensure that we were able to meet the production requirements of an application. For our executives who'd have to talk about what are we doing with big data, we created a pitch for them. Essentially, it's more MarkLogic, less Hadoop, all cloud native. MarkLogic is a NoSQL database that Northern Trust has been using for the past 24 months. It's an ACID-compliant NoSQL data store that we've adopted. It allows us to ingest JSON documents, XML documents. We can now leverage schema on read as well as model on read. As being part of a data architecture, modeling, governance, lineage, provenance, all of those components are core tenets of what we as a data program need to consider. MarkLogic helps solve that information for us to be able to embed within the original JSON document a lot of those components. So MarkLogic was key for us. So we had to evolve our architecture. We evolved it now to a message-based ingestion and processing. It's all cloud native, running on Pivotal Cloud Foundry. We have native support now for our JSON and XML. We have automated scaling and automated recoverability in our CI/CD pipelines. We've created a number of starter applications that help with onboarding new engineers, as well as when we're building new transformations. We've tried to keep the business logic itself out of our technical logic so we can use the integration patterns to ensure that we're actually staying true to what we're trying to do and focusing on the business logic when we need to, not trying to collide everything together. So now as a result of this, we've been able to realign our business objectives. We have a faster time to market. We've been able to streamline our transformation program alignment and strengthen our platform for future growth. And again, our coup de grace, we are cloud vendor agnostic architecture. So we've been able to realign ourselves back with the business as well as our transformation programs. We have actually delivered to our customer bases what was previously 6-month delivery cycles or quarterly. We're now able to deliver features within 4 weeks. With some of our features actually be delivered faster than 4 weeks, but we use 4 weeks as our estimation to determine from soup to nuts to be able to deliver something to an API for our consumers, which has been very instrumental in our success over the past couple of months. Just as a quick reminder, this is what we're coming from. Now, here's what we went to. This is an interesting slide because it's really showing us how we've moved from our big data architecture into a cloud-native stream-based architecture. We still have our multiple systems of record that come into our system. We read these files, process them as a message stream using RabbitMQ. We use Spring integration, Spring Cloud, Spring Boot, all of it. We still need to go through the common record transformations. That doesn't change. We still need to harmonize all of our different systems of record into a common record format that can then be used for our models, right? How we deliver data to our consumers, because we want to hide the details of 2 accounting systems or 3 accounting systems and really leverage, here is how your accounting data or your security master data really looks like. So we use MarkLogic, we still have our Oracle Exadata, but essentially all of this is running within Pivotal Cloud Foundry for our APIs, for our transformations. The only components that are not within Pivotal Cloud Foundry is our Hadoop, which we still use for archive, our MarkLogic, which is our ODS, which has our NoSQL data, and our Oracle Exadata at this point. Moving and looking at 2019 and 2020, we are interested and we are investigating migrating off of RabbitMQ into using Kafka as an event data fabric. The features that we're looking for with Kafka is more technical versus financial. The components that we're looking at here, as I mentioned earlier, is we're looking at our source system as it changes and then being able to create a transformation or transaction on the outbound side. So the components that are needed for that transaction are created within 30 seconds of each other, and that's really given some delay. The reality is we keep going after our ODS for some of the static data, that if we had the data within a Kafka pipeline, we're able to read that Kafka pipeline directly versus having to hit our ODS. So we can actually reduce some of the hit count to our ODS and including the data warehouse by having that data within our Kafka tables, or K-tables. So where are we now? We've talked about how we're able to get faster time to market. We've talked through our transformation program alignment. We're able to get better program alignment for our future growth, as well as we're better for the cloud agnostic architectures. So our transformations, as we look at our new acquisitions, we're able to bring the data in from source system, straight through process right into our data warehouse, while it also lands in our NoSQL ODS. So we're really looking at how we can streamline those transformations so we don't need to apply additional processing on top of it. We're really striving for straight through for those transformational efforts itself. So what did we learn? We learned an incredible amount. The first thing that I'll talk about is TDD is not enough. We're here at SpringOne learning about test-driven development, Spring Boot, 15-factor, 12-factor applications, but TDD is not enough. We've created our own test harness. Our test harness sits on top of our application that allows us to create test files that look at all of our ETL that we do and actually prove that it works. Not just taking the TDD for granted, but actually going through a straight-through application that allows us to look at the filters that we'll use for Rabbit, the transformations that are built within the Spring integration pipelines. All of those components we test out within the application, not just on the TDD side. So our product assurance folks can tell the engineers when they've introduced something that has passed TDD, but the test harness has caught a bug. And this information, the number of test cases and the results of the tests, is all displayed on our build pipelines that we have throughout our floors. So we have our concourse pipeline of everything that's going on. We also have a dashboard of all of our tests. So when our dashboard goes red from our tests, our engineers know we need to start looking at something, because even though our feature may have passed the TDD test, it actually failed an integration test set up through the test harness. The other component that I'm sure we all know is everyone tells us production data can be copied to UAT, UAT equals prod. Well, I'm sure we've all learned UAT does not equal prod. So what I will also tell you is get to prod as fast as you can. In some cases, silent prod works, but really get to production as fast as you can, because you're going to learn the most about what you're dealing with only in production. The simple nuances of what UAT has are not relevant in prod. Database settings, configuration settings, everything's different. Prod is really the golden state of where you want to go. Metrics, metrics, more metrics, and even more metrics. Metrics is key. Trust the data. So from a metrics standpoint, understanding the transformations, understanding the data, understanding all of those components of your system are really key for you. Here's a metric for you. So we started this engagement in the beginning of the year. Since March, we have done 70 migrations to UAT. Here's another metric for you. We went to prod in April. As of Friday, we did 22 migrations to prod since April 1st. From a metric standpoint, our existing ETL teams, they're lucky if they do 1 migration per year or 2. We've done double digits. So from a metric standpoint, we're able to get data out to them faster for our business deliverables, and we're able to iterate faster. The number of folks that we have on each team as well is completely different. The one thing that I hope everyone takes away from this is this book. This book should be not new to anyone who's dealing with enterprise integration. The enterprise integration patterns, they have a section completely on messaging design patterns. This is really key. This is really key because it instills the fact that you can separate your business logic from your technology logic. When you look at the message design patterns, you have pipes, you have filters, you can inject components into your workflows, and it allows you to extrapolate the actual business logic from your technology logic. And that is key because it allows you to focus on what matters most. And there's also language agnostic samples and stuff like that. So, questions? I talked about a lot of stuff. I'm just curious if anyone has questions. Sure, go ahead. So the question was, as we move to PCF, do we have challenges with the size of the memory containers, correct?
How much memory are you using inside your container, the size of the file?
So investigate Spring integration. So with Spring integration, you are actually, Spring integration, Spring Cloud, because you can actually open a file, and as you're reading the file, route it directly to a message, so it's not increasing the amount of memory that you allocate for your AI. Great question. Go ahead. Sure, question is describing the test harness a little bit more. Absolutely, so the test harness that we have, we actually built it as part of one of our stories when we started with labs. And it was around just looking at our different test files and the different scenarios that we're running through. As an example, if I'm bringing in a field from a file and it depends on a lookup to another database or another file, is that data ready before we actually try to create the transaction on our ODS or in our data warehouse? So it's really doing that field by field comparison, doing those lookups based on the ETL as well as running different SQL to understand the timings. Does that help? Sure. There's
conversion of files to streaming. How do you do that? Because sometimes a file needs to be completely finished before another process can kick off.
So the question is, how do you process a file, reading it, and then have it go back into the stream?
And knowing when finished.
And knowing when the file is finished. So just like the other gentleman, between Spring Cloud Stream and Spring Integration, Spring Cloud Dataflow has built an adapter that actually does that for you. So we don't need to create it ourselves. We can use the SCDF framework because they have a file ingester pattern that allows you to do that. And honestly, we wrote zero code to make that work. That's out-of-the-box capability. Answer your question, sir?
Just related, from your source of record, you convert files to file files. Related to this question, what's the purpose of converting them without just natively streaming them with a connector like a JDBC connector or something?
Sure. So the question is, why do we have to transform the data and apply a schema before we ingest it into a message? So our source system is database logs. So the database logs we use IBM DB2 for our mainframe. So change data capture or change data discovery does not apply the column name for the data that it's writing to the file system. So you actually have to apply the schema to the file to load it into a message.
Okay. That's good.
Yes?
If I understood, architecturally, we had two problems that we tried to solve. Number one was the Hadoop immutable database. That created complexity for changing and querying. The other one was the processing was done through ETL as well as SQL. And in the target, you changed both elements of your engine, both the persistent storage as well as MarkLogic, and the processing pipeline changed to cloud data stream and the messaging processing. So fundamentally, which piece was really, as you look at it, in terms of you solve it, which piece was really the key change of the problem? Was it both or was it one?
So I want to repeat the question to make sure I'm understanding it correctly. So what the gentleman is asking is we solved two architectural problems. One was around Hadoop as an immutable database, and the other one was around the transformations. And are we solving for both of them? So the Hadoop itself, we were using Hadoop as our operational data store. So when you're loading data to Hive, you cannot create an insert, you cannot create an update. I'm sorry, you cannot create an update or a delete. So we solved that problem of the operational data store with MarkLogic. MarkLogic became our ODS. So with MarkLogic, its SDK allows you to create document. So with the URI that's defined for MarkLogic, it will either do the insert or update for you. You don't need to manage which one you're trying to do. So we solved MarkLogic being our ODS versus the Hive on Hadoop. So I think that answers your first question. The second question of the transformations within Hadoop itself in leveraging and either doing it on Hadoop or moving it towards the cloud native architecture. So if we're moving the ODS outside of Hadoop itself, it made no sense to keep the rest of our processing within Hadoop because we were using Hive as our ETL tool. We were using Impala as our ETL tool. So we wanted to bring that transformation logic back into Java and be able to leverage our Pivotal Cloud Foundry as our platform as a service there. Plus also for our scaling workloads and whatnot. There's a question in the back. So the question is, why did we use Spring integration versus staying on Spark streaming and stuff? Accurate? So when we started working with Spark, we were trying to leverage some of our existing architectures, but changing the transformations. And Spark honestly just didn't work out for us. We had a number of issues that we just decided that Spark really wasn't, it didn't make sense for us to stay with Spark. And so we actually had to pivot and come to Cloud Native and use Pivotal Cloud Foundry and the Spring integration stuff. So if there's any other questions, please see me afterwards. We can talk about any other questions that you have. I do want to mention that there is actually a very interesting talk that I'm looking at that I want to go take a look at, and it's bringing Agile, DevOps, and Lean to data. It's actually happening tomorrow at 12:10 to 12:40 in National Harbor, 12 to 13. Thank you.